closely at the back of your hand. From a macroscopic perspective, it appears to be a quiet, static surface, a simple biological wrapper keeping your insides neatly contained. But if we zoom in past the pores and hair follicles, that peaceful illusion shatters. Down at the cellular level, this surface is a chaotic, violently active environment. Every square inch of it is currently engaged in a continuous two-front war against incoming environmental radiation and swarms of opportunistic bacteria. If these microscopic defenses suddenly stopped functioning, the sterile environment of your internal organs would be compromised almost immediately. Within days, the body would succumb to widespread infection, fluid loss, and temperature dysregulation. We tend to think of the epidermis as a mere physical barricade, like a brick wall. The reality is that those tightly packed cells are supported by an expansive arsenal of active, highly specialized chemical and cellular weapons. Your skin is not a static container. It operates as the body's primary, most heavily armed first responder. The first major threat arrives from above. Every time you step outside, you are bombarded by an invisible spectrum of solar ultraviolet radiation. A fraction of this light consists of short-wavelength UVB rays. These rays strike the outermost layers of the epidermis, packing enough energy to cause immediate, direct structural damage to your cellular DNA. This diagram illustrates how the two primary types of UV light interact with our bodies. While the UVB rays stop near the surface, the longer UVA rays, which make up 95% of the solar radiation reaching the Earth, penetrate much deeper into the dermal layers. Because they bypass the surface, they inflict subtle genetic damage to cells on the innermost part of your top layer of skin, leading to long-term cancer mutations. Looking closely at the molecular level of this diagram, we can see exactly what that damage looks like. When a photon of UV radiation strikes a DNA double helix, the energy snaps the molecular bonds between adjacent bases, forcing them to fuse together abnormally. The intensity of this bombardment fluctuates. Altitude, latitude, time of day, and even reflective surfaces like snow all compound the radiation levels, which meteorologists measure and forecast using the standard UV index scale. From a biological perspective, sunlight is a daily, relentless bombardment of radiation attempting to mutate your cellular genetic code. To survive this daily onslaught, the body relies on a specialized biological counteroffensive known as the epidermal melanin unit. When DNA photodamage occurs, it acts as a distress signal. That signal triggers a eukaryotic SOS response. The visible result of that emergency response is what we commonly refer to as a tan. Deep within the epidermis, specialized cells called melanocytes begin producing granules of pigment. These dark melanin granules actively migrate upward through the cellular layers. Once they reach the upper skin cells, they arrange themselves into physical shields, forming protective caps directly over the cell nuclei to block incoming rays. While a person's baseline constitutive pigmentation, classified scientifically as skin phototypes I through VI, determines how much natural protection they start with, darker skin only delays the inevitable. Clinical studies confirm that no human skin is entirely UV resistant. A darkening complexion is the visible evidence of genetic distress. A tan is the physical scar left behind by a microscopic war your skin fought to protect your DNA. While managing the threat from the sky, the skin is simultaneously fighting a ground war. The surface is constantly exposed to opportunistic, virulent pathogens like Staphylococcus aureus. The first line of defense is structural. Millions of tightly packed keratinocyte cells, cemented together by biochemical lipids called ceramides, create a dense physical barricade that is exceptionally difficult for microbes to penetrate. Patrolling this barricade is a diverse community of microorganisms known as the skin microbiome. These friendly bacteria act as biological first responders, aggressively outcompeting harmful pathogen strains for space and resources. The skin also deploys a form of chemical warfare. It continuously secretes fatty acids, defrensins, and lysozymes across its surface. This chemical mixture drops the pH level, creating a highly acidic, toxic environment that disrupts and destroys bacterial cell walls. This diagram shows the skin's ultimate targeted weapon against highly resilient, drug-resistant bacterial invaders, a molecule known as a cationic antimicrobial peptide, or CAMP. Looking at the molecular structure, we can see how highly evolved these peptides are. When an invading bacterium deploys protease enzymes to chew through the skin's defenses, Structural disulfide bridges on the CAMP molecule act like steel reinforcements. They effectively jam and break the bacterial enzymes, rendering the pathogen powerless. The epidermis actively hunts and neutralizes pathogens, deploying an arsenal of chemical weapons to suppress invaders before they can take hold. Because this system is so complex, any disruption in its physical, chemical, or immunologic properties leaves the body highly vulnerable. When the barrier breaks down, the immune system overreacts to the resulting microbial infiltration. This dysfunction is the underlying driver of severe dermatologic conditions, including psoriasis and atopic dermatitis. Modern pharmacology is learning to mimic the skin's own defenses. By developing topical emollients rich in ceramide-based mixtures, medical treatments can biochemically signal the skin's cellular pathways to rebuild and restore the fractured barrier. Psoriasis and dermatitis represent critical, localized breaches in the body's primary immune fortress, where the microscopic wall has effectively collapsed. The surface you see in the mirror is the site of a perpetual, invisible struggle. Every day it manages a lethal crossfire of incoming radiation and opportunistic microbes. The notion of a healthy glow or a safe tan is a biological myth. A darkening complexion is the visible metric of active genetic distress. By taking deliberate steps to physically shield ourselves from excessive UV exposure, we stop forcing the skin to divert its energy toward emergency DNA repair. That allows it to conserve its resources for the daily war against pathogens. Human skin is a dynamic, living shield. It is actively fighting a war on two fronts to keep you alive, every single day.